Let me stop sharing this one. I'm going to share with you the PDF PDF file. It's much better so that I can write something on the skin. Do you have it? Let's share now. Share the PDF which is here. Do you have this one? Example in class. Slide page number 52. Thank you, Ang. Okay, this is not in your notes. I mean in your books. This is in your slide, the additional material that I provide you on in groups WhatsApp group. Yeah. Okay. I'm going to explain typically not in detail because we will complete the whole thing, isn't it? So I'm going to explain how to go about it. For example, how to manage or to start the solution. Okay, you have 4-stroke here, 4-stroke engine, no doubt about it. You have theta is equal to 720 by n, right? To define what be the position, theta position. And with 5 cylinders, so your n will be 5. This one will be 5. Inline engine running with constant speed, omega. Okay, is a variable on omega. And the cylinder are numbered 1 to 5 sequentially. 1n and the fine order is 1 5. This one given 1 5 2 3. Even it's not given. Yeah, I think I already discussed about how to design the fine order. Yeah? The reciprocity mass corresponding to each cylinder is mkg. Again, variable, a constant variable, isn't it? So investigate the balancing of the given engine, the 5-cylinder 4-stroke engine. Okay, so this is the solution. This one, yeah. First, because we already decided that we're going to solve this one by using graphical, so it's compulsory for us to construct a table. So constructing table is not a big deal because we have been doing this one in your roto balancings. So the only difference now, you have another one, additional. This one is additional. Isn't it additional? Yeah, this is the additional column compared to what you have earlier. The other one is the plane, perhaps, if I may say that it's a plane. So plane that I would like to advise you to follow one firing order. Look at here, 1 5 2 4 3 given. So you have all you have, yeah, MR. So the one that you don't have is the D. Remember, the D is to select the reference plane. Again, there is no reference plane. The unknown parameters seem that every parameter are unknowns. Obtained, isn't it? What you need to know is to define what be the reference plane. So the reference plane is what you cut into 2 parts symmetrically. So this one is number 1 to number 5. Then you cut into 2. This one will be your reference. Then you decided that okay, toward your left or toward your right is positive. The other one is negative. So there is you have this one 0 because reference plane. Okay. So the next thing will be what you have. The next thing is, let me close my one. The next thing what you have is, every cylinder will be referred to 3. For example, yeah, 2 to 3, for example. So you have 1, 2, 3 is D. Okay, the negative D. So 2 here, negative D. So on and so forth. Remember, yeah, the reference plane is where? Is the symmetry of the engine when you cut into 2 parts and it falls at the center. So then you have the magnitude of force. You can look at the magnitude of force. All are the same because this is one is constant parameter. This M and R is constant parameter. Also the force are also constant parameter. Except unless you have to be talking about compressor, for example, because compressor have multi stages. Yeah, different in performance of the engine or in the compressor. Yeah, or cylinder. And the next one is couple. You look at the couple, you have different in magnitudes. And of course, this one is the arrangement when you decided, to look at the 0 be at the vertical plane. This 144 divided by for this one. And this one is very crucial, very important. You do this one from the very beginning of your solution. 720 by 5 you have 144. So everyone will be what will be double by 144. Sorry, by 144 by 144. Additional 144, 144 up to 576. Following what? Following this one is the firing order. So the next one, this one is the primary. The next in the secondary is twice from what you have from the primary. You just multiply by 2 or divided, plus 144 plus another 144. Okay, so this one given, very fortunate. So the next thing is what? To construct polygon. You have 4 polygon to be constructed. That is how you create or perhaps design the table. Constructing the polygon is not very difficult. This one is primary force polygon. Primary, this is force. Primary will be this one. This is primary. This one is secondary. So this one is, you have what? You have MR versus theta. This one, put it there. MR versus theta. Then you start constructing this one, isn't it? It's not very difficult, yeah. So I also mentioned earlier, the most important thing is this one, the crank diagram. Remember your crank diagram? Remember your crank diagram, class? Anyone down about crank diagram or the crank position? Before you start anything, remember this one is compulsory. Okay, I think everyone know because there's no response from class. So I suppose that you have already understand how to create or perhaps decide where will be your crank diagram or crank position. Yeah, then you start constructing this one. Okay, you have one. Look at the defined order just now. What is defined order just now? Is 1 1 5 2 4 3 1 5 1 5 2 4 3. Look at 1 and 5 is 144, isn't it? You have 360 divided by 5, you have 72. But this one will be away 144 degrees. So this be one, your reference. This reference and this one and this one is not the same, yeah. This one reference for what? For plane. This one reference for position. It's not the same. This one for plane. Also reference but for plane. This one is the position reference. So 1, this one will be 5. Okay. Okay, next you have 2. Again, another 144. 2 will be here because this one will move. 2 will move 2 here. The next one is 4 will here because you have 2. This one 2. 144, 144. The next one is 1. 3 will be here because this one be another 144. And this is your reference position. And it seems that it is balanced because everyone located at the or same or angles, acute angle 72 degrees. So this one is balanced. So you have F primary equal to 0, balance. Okay, you move to the next one. Primary couple. Remember, when you want to create primary couple, you have to know the magnitudes, isn't it? You have to know the magnitudes. Because why? You have to construct the polygons. So I'm not going to do this one in detail. You have to do this one on your own class. So after do the same thing now, you'll be getting this one not balanced. Why? You have this one 2, this one you have 2, this one you have MRD, this one MRD. If you construct the polygon, you have the open polygons. You have to close the polygon, isn't it? So not balanced. You're not balanced, yeah. The next one, you move to the next one. And it is balanced. This is the force. Now is the MR versus 2 theta. Isn't it? You have 0, 288. 288 is 1. 288 will be 144, 104. So this one is 1. This one will be 5. We have 288. On and on, it is balanced now. And if you move on to the last polygon here, you found that it's also not balanced. It is not balanced here. So it is not balanced. So in conclusion, you found that there are terms that are balanced, there are terms that is not balanced. Okay, then you have the conclusion. And we move to the next one. Example number 5 is 6-cylinder. Look at this one, class. 6-cylinder. And 6-cylinder, they provide you the firing order. And we do exactly the same. You have start with theta, 720 by 6. You will have 120. So everyone will be located 120. So you will have this one. The location is not the location of cylinder, yeah, the location of crank basically. The location of crank when you look at one end. So this is the the engine stand. So you have to look for reference, cut into two parts symmetrically. So it will fall here. So everyone will refer to this one. So there's no cylinder, yeah. So you look at here and you have all this one, and you have all parameter. Then you start construct polygon. Construct polygon here. It seems that this one is balanced. You have a very nice polygon, isn't it? And also represented by the crank diagram. You move on. Look at also the couple now, also a closed polygon. You move on now. I want to give you a conclusion. Yeah, this one also balance. Refer to this one, and finally, and look at this one for secondary, also balance. So I will make a conclusion now. So the one that is not balanced is what we call as counterweight, isn't it? So you have this one. This one is not balanced just now. You do the counterweight. Remember in my discussion earlier, you have a mass which is not balanced here. How do you balance another mass? But opposite direction. As long as the magnitude is mr, this one also mr, doesn't matter how big the mass is and how long will be the crank. It's supposingly this one is this one is r and this one is m. This one could have 2m but half r, isn't it? It doesn't matter as long you have this one mr and this one also mr. Okay, but of course this one we have only one cylinder. If you have so many cylinders, we have a multi cylinder. You will have what? You have F equal to F primary plus F secondary. Then you know what will be the mass. Force. The other one is M equal to M primary plus M secondary. You have another. Correct. So you have this one. So this one representing the unbalanced parameter, which representing by this one. Okay. So is basically there is no mass added to the cylinder. The only mass added to the system is the crank. So you are basically what balance the crank. Okay, you are basically balance the cranks. I have a video here, but very unfortunate I can't find the video. If I can't find the video, if I find the video, I will share with you. Yeah. Okay, so let me complete with the with the analysis. Where? I think you have the analysis with you, isn't it? Let me check. You hold on. If you go to your books here, I do make a conclusion here. Yeah. This is the new slide. So there is why I think a couple of things is not included in the slide. So never mind. If you look at your notes, what I can see here, the inline engine, yeah, remember that is the inline engine. The engine will be totally balanced. Start with 6-cylinder. With appropriate or with accurate firing order. So you will have a very nice balancing. Okay, start with 6-cylinder. If you have a very good firing order, so you will have very nice engine. So none of the parameters not balanced. Okay, so let me let me take you a couple of minutes because I really want to share with you this one. Yeah. Hold on a bit. I'm going to share with you a video. I think I know where I put the video now. It's a 1 minute class. Listen to teaching video. Teaching video is not teaching video. That one is last. Where are you? 1 minute. I already found the one, but now it's not here. Educational video teaching balancing of crank balancing. Yes, this is crank balancing. Crank balancing. Yes. Okay, let me share with you. Share with you this one. I'm going to share the video here. Start share. Do you have a sound video class? Do you have a sound? Yes or no?
No, there.
No. Okay. Thank you. So I'm going to let me share. Let me share content multimedia. Share cancel. Stop sharing. 1 minute. Share what? Share. Do you have a sound with you now? Yes or no?
Still no.
Anyone? Would anyone respond? No sound. Okay. One again. Yeah, again. If I can't do this one, so let us now share whatever you have. Let me share. Share what? Share video. Okay, share video. Share video. So I'm going to play back the video. So look at my book. Be careful. This is about balancing an engine. It is basically not balance the engine. Basically balancing of the crankshaft. When you have one cylinder, we call it we call it crank. When you have so many cylinders, we call it crankshaft because the crank basically located or attached to the shaft. So this one, listen up and focus on this one. Yeah. So this is the crank with cylinders 1, 2, 3, 4, 5, 6, 7, 8 cylinders. So this is the crankshaft here. So they are basically balancing the crankshaft by what? By adjustment. Remember, when you can add mass and you can also take away mass. So I'm going to share with you how is it take away and add mass to the system. Yeah. So I will explain you a bit. This one the crank. So here this one the encoder. To define will be the position of the crank. This attached with the encoder and go to the analyzer. So the analyzer basically display all parameter which is not balanced or also balanced. Yeah. Okay, one more, yeah. One more. Red in color. This one red in color. So red in color, what does it mean? It is not balanced now. Okay, so start all over again by take away mass. It is not very difficult for you to add up mass here. It's better for you to take away by grinding a bit at certain position which is shown by the analyzer. Yeah, this one. This is grinding a bit, isn't it? not balanced, look at the numbers. Of course, we cannot see the numbers. Yeah, the value which is not balanced. And the position also. Look at here, 0 and 0. So basically what you've been doing here, it's not to balance the engine. You basically balance the crank. After you balance the crank, then crank is so balanced, then you put all the crank connecting rod and also the cylinder. As I mentioned earlier, the connecting rod, the cylinder are basically what is identical parameter. Isn't it? Same weight, same material, so on and so forth. Same dimensions, so on and so forth. Okay? So those. So I think that's about it. Any question, class? So if there is no question, I'm going to move to my next lecture, which is on, where are you? Where are you? This one, yeah. Share with. Minute class. Close all files. So many files open. This one very difficult. So I'm going to sort here a bit. You have this one. So let me share with you now. I'm going to share new topics. Share. Do you have the new screen now with you? The topic we're going to talk about today, for today lecture. Yes or no? Yes, thank you. So we complete the inline engine. So this is another engine which is also reciprocating mass, but the arrangement of the engine is different compared to what you have earlier. So first, let's start with this one. I cannot move. 1 minute. Why this one? Okay. Okay, this one. Balancing of reciprocating mass, V engine, and also radial engine. We are going to start with radial engine first. So we are going to discuss about first the introduction of radial engine and the V engine. So what is the difference between radial engine and V engine? The most important thing is the similarity of the radial engine and V engine, because if you look at the inline engine, it's very different compared to radial and also V engine. So as the radial engine and V engine is so similar in terms of balancing the engine, we are going to use the same method. Of course, this method cannot be used, or the method that we learned earlier in inline engine cannot also be used in the radial engine and V engine, because it's so different from the arrangement or configuration of the engine. The only thing that same is the unbalanced inertia. Remember, the unbalanced inertia is F equal to m omega square cos theta plus mr omega square cos 2 theta divided by n. Well, your n will be the ratio between the connecting rod divided by the crank weight. So that is identical, also same, because we are talking about the same unbalanced or same inertia on the internal combustion engine. The only difference now you have is you have the direct engine, direct crank and reverse crank. So this is the difference now. What you have the inline engine, only direct crank. There is no reverse crank. Here you have direct and reverse crank. So that is why the method that we used earlier in inline engine cannot be used for this engine. But for the radial engine and the V engine, you can use both, because the radial engine and V engine has direct and reverse crank. So what is the direct crank and reverse crank? I'm going to share with you, define to you what is the direct and reverse cam when we meet the subtopics. Then this one is balanced distributive mass. Is a multi. Of course, we are talking about multi different plane. We are going to talk multi cylinder, radial, and V engine. And here is still doing the same thing, primary and secondary inertia, because you are using the same equation, but yet you have the direct force. So you have primary direct force, secondary direct force. You have primary reverse force, secondary reverse force, isn't it? So you have four now. From primary, you have direct and reverse. Secondary, so you have also direct. So you have four polygon now, four different equations. So the next thing will be couple. Of course, you're talking about couple logically. You found that there must be couple primary, couple secondary, couple primary direct, couple primary reverse. But I'm going to share with you what happened to couple or moment here. So look at here. So this is the radial engine. Look at here. So the beauty thing of this engine, you only have one common crank. One common crank. Look at here the crank here. This one is the crank. Can you see my arrow here, my cursor here? I'm pointing to the crank now. So every connecting rod, it will be connected to the crank. So what we call is a common crank, isn't it? So you have 5 cylinder, and the 5 cylinder is connected to the common crank, isn't it? Then only carry or attach to the cylinder connecting rod. This is connecting rod. This one is common crank. Okay, the cylinder or perhaps the piston will be always reciprocate. The only now is a rotating thing is the crank. And look at the green color, the other side, the rear part there, the front part of the others from the other side. The green one, the light green one that keep rotating is what we call the unbalanced mass or balanced mass to balance the engine. We are basically looking for something to put on the green one, to represent the green one. Whatever you feel is not balanced is represented by the green one. Okay, so that is the radial engine. So look at the arrangement or perhaps the configuration. So the arrangement will be in one circle. Isn't it? It will be one circle divided by the equiangle. So when you divide it by equiangle, it simply means that you have 360 divided by 5. You'll be getting a such 72 degrees just now as what we have earlier. Okay. So that is one. The other one, you look at the V engine here. You have V6 here. Look at V6. This is the animation. This is not the actual one. Yeah, the actual one will be seeing you inshallah the lecture one. So look at the actual one, the bottom one. So this is the actual one. So if you found that here, you found that cylinder number 1 and cylinder number 2 attached by one crank. If you look at my cursor, yeah, this one is one crank. Connecting one, this one connecting one, connect to one crank. And this is again what you call as common crank. But the common crank is only carry 2 cylinders, cylinder 1 and 2. Another common crank carries cylinder number 3 and 4. Another common crank carries cylinder number 5 and 6. So if you have 6 V6 or 6 cylinder, you have three common crank, isn't it? Because one common crank carry 2 cylinders. So you have 6 cylinder, you have 3 common crank. And that common crank carries cylinder number 1 and number 2 we call as bank, B-A-N-K bank. So one bank carry 2 cylinders. So one bank has one common crank. If you have 6 cylinders now, how many bank do you have? Do anyone answer me? How many bank do you have? You have 6 cylinders. 3, yes, you have 3 bank. If you have 12 cylinder, how many bank you have? 12 cylinder. You have 6. So we call V12, but you have 6 bank. One bank carry 2 cylinders. Okay, the position of the crank will be talking later on. Yeah, so that is the only difference now. So different thing will be, if you look at the common crank, is exactly as the radial, but for the radial engine there is no one. There is no arrangement of bank. If you have 12 cylinder, will be located in one circle. But for the V engine, when you have only one bank carry 2 cylinder, we call it twin engine. You have 6 cylinder, you have 3 bank, where one bank carry 2 cylinders and attached to a common crank. Okay. Even with so many cylinders, yeah. Let's say you have V12 for example. V12 you have 6 cylinders. Sorry, you have 6 bank. Even if you have 6 bank, you know that the identical of the connecting rod and also piston. So you can also focus on one bank and do the analysis, because whatever you have from one bank will be also carried by the next banks. This one, another one. This is just to show you the different. Yeah, this is a radial engine. Look at the green one, the light green. The light green one is the what you call it, the balancer. This one, the balancer can put one-sided or two-sided. Yeah, the blue one, this one, two-sided. So it's up to you how do you design. If you have a big compartment, you can use two-sided. You have a small compartment, you have to do one-sided. This one, yeah. And this one, look at, yeah, another one. This one only one-sided, the top one. This is the balancer. The balancer is basically coming from the unbalanced mass or unbalanced force that you created, that you calculated. Then you turn the unbalanced force to become a mass. Look at the other one here. This one also the unbalanced, the unbalanced mass presenting by this one balancer. Okay, this one is the use or perhaps the exposure of the radial engine to the engineering worlds. Can be used as light aircraft, can also be used as motorbikes. This one is the right. If you are a rider, you might be thinking of using this one because this one is very good in term performance, also handling. For the V engine here, look at the position of the engine as I mentioned earlier. This one have 1, 2, 3, 4. You have 8 cylinders. So 8 cylinder you have 4 bank, isn't it? And 1 bank you have common crank. Yeah, this one also same thing. This one, this is the animation. This one is the actual things. This is the actual engines. And if you observe very carefully, you find at one time 2 cylinders. Yeah, 2 cylinders will be acting in one activities. This is another one. This one is V6, which is very common and very famous nowadays compared to the inline engines. This one is a V8. This one is the, as I mentioned to you earlier, the firing order and also the position of numbering the engine. Yeah, one will be zigzag here. This one, yeah, zigzag. The other one is a one-sided. 1, 2, 3, 4. The other one start the 5, 6, 8. This one all horizontal. This one is zigzags. So it depends on what type of engine you deal with. This one rotating clockwise. The other one rotating counterclockwise. So different engine will have different perspective or different parameter or different arrangements. This is the arrangement of, as I mentioned earlier, for the firing order. Look at the 1, 5, 4, 8, 6, 3, 7, 2, and you know how to design this one, design the firing order, isn't it? We already done this one earlier. So if you look at one point here, this will be the what you call as crank. This is the crank position. Okay, the crank position. So now is about is the time to know how to balance the engine. We already have a overview of what is the arrangement look like typically for the radial and also the engine. Now is the time to use the knowledge to balance the engine. This is the animation. This one is the actual thing, the actual engine. Yeah. So remember this one. The method we are going to use is direct and reverse crank. What is the direct crank? What the reverse crank? I'm going to explain to you a bit. Yeah. I'm going to use a very simple methods, what we call as graphical, and it is simple and accurate method. You can also use analytical. If I have ample of time, I'm going to share with the analytical. But at the moment now, I'm going to focus on graphicals. What is the graphical? Is constructing or construction of polygons. The polygon must be constructed, by refer to the crank diagram. So we are going to use the crank diagram now. This one is not a big deal, as I mentioned earlier. These are all the the inertia of the unbalanced force. You have this one will be the primary, the first part. The second part will be the secondary. This one is exactly as what you have in the inline engine. Okay. The other one is you can split into 2 parts. The front one will be the primary balance, primary force. The other one secondary force. But this time around, you will have what? You will have this one, yeah. You look at this one. You will have primary direct, secondary direct, isn't it? primary reverse, secondary reverse. We have four different equation now. Okay. So the primary have two now, direct and reverse. The secondary also have direct and reverse. I'm going to explain later on what is direct and reverse a bit. This is the couples. Look at the equation, no change. This one been used in the inline engine. This one the primary couple, this one the secondary couple. But this time around you have what? Primary couple, direct crank, primary couple, secondary crank. Reverse crank, secondary couple, direct crank, secondary couple, reverse crank. You have four now, isn't it? Four now, compared to two earlier. So as I mentioned earlier, yeah, the arrangement of the engine is different compared to what you have in the inline engine. So this is the inline engine. Look at this one very careful, class. Okay, as this one rotating, this one you pause a bit, you found that this one the radius, is radius. Can you see my cursor, class? I'm pointing my cursor here. Can you see the cursor now? Yes, thank you. And this is the radius, crank radius, typically represented by this one. And it'll be creating a circle. This one, the crank will be connected to connecting rod. This is connecting rod. Connecting rod will be here. This one connecting rod, and you have the R stand for the radius. The L, the capital L stand for the connecting rod, and toward the end is this cylinder, which is identical. So the connecting rod and the crank will be the piston are identical for every cylinder. Okay, so if you look at from one end, for example, this one the front view, this is the front view now, this is the side view. So you look at the position here. If I may say that from top of your horizontal is 0 degrees, so this one will be 180, 0, 0, 180. Correct. That is the position of the crank. Okay, at one time when you pause it, this is the position. And you found that, look at down here, you found that the position from one crank to another crank we call D. D, the distance from one plane of the cylinder to another plane of the cylinder. So you have two equations here. This one is F UB is unbalanced, MR omega squared cos theta plus MR omega squared cos theta n. This one is for all forces. When you have the force, then you multiply by D, you have a couple. Isn't it? So this one is so obvious, what you learned earlier. Okay, now I'm going to share with you the difference between the inline and also radial engine. So as I mentioned earlier, the equation that we use here is exactly the same. For example, pick up one example, one equation for force. Yeah, the first part of the equation is what we call as primary. This one is secondary. You put here F primary, F secondary, no change. Okay, but look at the arrangement. The arrangement will be in one circle. Look at here. This one is not correct. Yeah, this one is supposed to be. This one is not correct. I wrongly put the numbers of cylinder. This one is supposed to be. Astaghfirullahaladzim. This one is supposed to be 2. It's not 3. This one is cylinder number 1, number 2, number 3, number 4, number 5. Correct. Number 6, 7, and 9. This one is supposed to be number 2. It's not 3. Yeah. Can you hear me, class? Yes, thank you. Oh, where are we just now? I lost this one. This one is supposed to be number 2. Cylinder number sequentially. The primary force, the secondary force are exactly the same. Look at the position now. The arrangement of the cylinder, the arrangement of the engine will be in one circle. So you have theta divided by number of cylinder. How many cylinder? You have 9 cylinder. So 360 divided by 9, you will have, what do you have? 360 by 9? Anyone? 360 by 9. Anyone? 360 by 9. What is the position for 1? Is 40. So from cylinder number 1 to cylinder number 2, you have the equi-angle with 40 degrees. Look at here, this one, 40 degrees. This theta will be 40 degrees. You have theta here, theta here, theta here, and you back around, you will become 360 for 9 cylinder. If you have 4 cylinder, for example, let's say 4 cylinder, you have 360 divided by 4, so only 90. So the space, we call it the space, yeah. The space between cylinder number 1 and cylinder number 2 is basically by what? Equi-angle by theta here. Okay, so when this thing will be keep rotating, yeah, This crank will be keep rotating, and the engine will keep what? Reciprocate from from bottom dead center to top dead center to create the four activity: induction, compression, power, and also exhaust. Correct. So if you look at here, you have F6. F6 will be what? The force on cylinder number 6. This one will be the force on cylinder number 5. So the equation will be as what you have here. Okay. But look at the moment. Look at the moment. What is the equation for moment? Force multiplied by 1. What is the equation for moment or couple? Force multiplied by 1. Anyone? What the equation for moment or couple? Force multiplied by distance. Correct. Force multiplied by distance. So do you find any distance from one plane to another plane here? And so the definition for couple is, force multiplied by distance perpendicular. Look at you have to look for the vector. Yeah, force multiplied by distance perpendicular. So this one, what you have force, correct, but there's no distance perpendicular to the F. No, isn't it? So that is why you have what? D will become 0. D will become 0. So no couple. So if the question asks you why there is no moment on the radial engine, so this is the answer, because there is no distance what perpendicular to the force creating moment or couple. So in conclusion, that is why now people are now keep on focusing on radial engine, because they believe that, and the researcher found that the radial engine make in terms of handling is very comfort compared to inline engine. Comfort meaning the handling is so good, so smooth compared to the inline engine. Vibration is so little, or perhaps so small compared to the inline engine. But in other word, if in other in other perspective, you find that doing maintenance, for example, maintenance. Let's say cylinder number 1 now have problem in this cylinder ring, for example, piston ring. So when the piston ring is broke or break, for example, you found that you have to what? You have to pick up only cylinder number 1. But here you have to what? You have to dismantle the whole cylinder, because this one is connected to common crank. But here, if you found that only cylinder number 1, for example, having problem here, you are focusing on cylinder number 1. You are not touching any part of the other cylinder. Here you need to dismantle the whole thing. So this is the advantage of a radial engine compared to the inline engine. That's why you found that the workmanship of the radial engine is very much higher compared to the inline engine. I'm not saying that this is not good. I'm saying what one thing you have a good, the other thing you also need to counter back. Yeah. Okay. So this is the initial force. So we found that the moment is not exist. So by primary force, secondary force. But you have to understand that the primary force is secondary. The primary force is direct crank and reverse crank. This also direct crank, reverse crank. So I'm going to talk about what is direct crank and reverse crank. Yeah. Look at here. So there is no moment, zero moment here. There is no zero moment, so you found that the engine now has less more force acting on the engine, isn't it? It's so logic, isn't it? Because you are basically what you are putting away all the moment existing in the engine. Okay. Before we go to this one, perhaps this one, correct, direct and reverse crank, I would like to share with you this one, the arrangement. This is 5 cylinder. This one is 4 cylinder. No doubt about it. So this one rotating counterclockwise from your seat. This one's rotating counter from your seat. So look at this one. This one is what we call as connecting rod. This one is connecting rod. The dotted line here representing what you call it line of stroke. This one is the circle made by the connecting rod. Sorry, made by the crank is called crank diagram. The numbering of 1, 2, 3, and 4 is the engine numbers or cylinder number, and the direction for rotating counterclockwise, what we call this direction of rotation. The most important thing here is the position for the crank, common crank, and also the line of stroke. Okay, the most important thing here is the line of stroke, which is represented by the dotted line. The other one will be common crank. So if you know these two, inshallah, the next thing will be very easy for you. If you have 4 cylinder, for example, you have theta divided by 4. It make you 90 degrees for every cylinder. If you have 5 cylinder, for example, so you make the equi-angle of 72 degree every cylinder. Okay, V engine. Okay, the position for the engine now is you have so many banks. Look, you have, let's say you have this one is V6. So you have V6. You know that the piston and also the connecting also identical. So you bring out only one bank. You bring one on bank, put it here. So this one is only one bank, and you have only 2 cylinders. Bank number 1, for example. Bank number 1 carries cylinder number 1 and number 2. Bank number 2 carry cylinder number 3 and 4. The next one be bank number 3 carrying number 5 and 6 as cylinder. Yeah. So this one is the crank located at verticals. The crank located at verticals. What you call crank, common crank carrying cylinder number 1 and 2. This one be connecting rod. The creation of the crank rotating counterclockwise seat we call it as the crank diagram. The position will be vertical. Can it located at horizontal? Yes. Can it located at line also? Yes. It's up to you. It's up to you where you want to locate the common crank. Okay. The next the next one I will explain to you what is the best position of the common crank to make the easy calculation in your work. Yeah. Okay. The other thing is most important is what we call as V notch, NOTCH, or V shape. So the V notch or V shape is basically measured from the line of stroke to another line of strokes. That is the V notch. Let's say the questions ask you give you information like the V6 at 60 degree V notch. So it simply means that measured from the vertical 30 degrees away, another one 30 degrees away, with measured from line of stroke for cylinder number 2 to line of stroke to cylinder number 1. Okay, so this is what we call V notch. We have the equi-angle again. Okay, so that is the introduction of the whole thing, the arrangement, the force, the inertia, how to balance it, and the position for the crank. So the next one will be how to balance the engine. Okay, what I've been showing here, if you have video notes, this is what is the counterweight or balance, or balancer. Sometimes we call balancer, sometimes we call counterweight, to counter the unbalanced mass or unbalanced weight. Look at the green here, it's one-sided, this one is two-sided, this one also two-sided. Who decide one-sided, two-sided? You, if you are, if typically you are talking about the automobile engineer, you are going to decide whether it's good for one-sided or two-sided. If you're asking me, I have no idea, and basically whether the two-sided and one-sided is good or not. I have no idea actually. Yeah. But logically, two-sided is much preferable compared to one-sided because it basically what balance the engines. Okay, now this is the direct and reverse class. So I'm not going to use this one. I'm going to I'm going to stop sharing here. I'm going to share with you. This one is the share with you. Where are you? I'm going to share with you. Yeah, the PowerPoint, the PDF. Minute class. This one. Share with this one. Okay. Share now. Share now. Are you? This one. Do you have a new screen in PDF form? Do you have it? Yes or no? Thank you, Cole. Look at here. We stop and this one. So this is the what you call it, the procedure how to balance the radian and also the engine. This is not very careful, this one, yeah. It is not very difficult, but once it's stick in your head, inshallah, yeah, you can use this one as your as your knowledge to solve any part of the problem related to the cost, of course. Yeah. So look at here, direct crank and reverse crank. I'm going to use this one. This one is direct and reverse. So what is the direct crank? So listen up very careful. Direct crank is the actual crank. So put it here. This one is the actual crank. The actual crank. Okay, so the actual crank will be, if you're talking about this one, not good. This one. This is the actual crank. Okay, now I'm going to move to another one. Oh, what happened now? Something wrong with this. You still have the screen with you? Because something happened to my. Yes, thank you, Ang. Yeah. Okay, now now is the procedure. So that is the actual crank. So what is the reverse crank? Listen up very careful. The reverse crank is basically the image, image, or reflection. Image reflection is basically the same, yeah. Image of the reflection of the actual crank. So what is the image? For example, you stand in front of the mirror. You put up your hand up, your right hand up. So tell me what the mirror tell you. The mirror, your image will be putting up right hand or left hand. Imagine now you stand in front of the mirror, you put up your right hand. So the mirror, your image will be what, putting up right hand or left hand? Left hand. So the image, right? So it's basically opposite from the actuals, correct? So if it is opposite of the actual, so this is the actual one. This one, the actual one. You have a mirror here. You place mirror here. Of course, in the engine, there's no mirror. Yeah, don't tell me you open up the engine, you find no mirror. No, this one is what you call it, the procedure. Probably one is the method to bend the engine. You have a mirror. You place the mirror here, so it will give you a reflection. So you have the reflection exactly the same. If this one is 45 degrees, for example, so this one also give you 45 degrees, but you have negative because why? The opposite direction. Okay. So initially, if there is no, for example, there is no reverse, you have M here, but now you have two crank, isn't it? You have two crank now. You have one crank, which is coming from the actual thing, of course. The other one, you have the reverse one. So you have to divide the M by 2 instead of having only one M. So M, half M, another half M. Even though this one is not the actual, then this one is what we call it virtual. But you have to take into account. So if the crank, the common crank rotating counterclockwise, this one, yeah, counterclockwise from your seat. And this guy, the crank now, the reverse crank will be rotating clockwise from your seats. So that is the difference between direct crank and reverse crank. Where do you find the direct crank and reverse crank? Where do you find? Where do you find? Could anyone answer me? Where do you find the direct crank and reverse crank? Hello? Anyone? No one bothered to answer my question. Where do you find the reverse crank? Radial crank. Another one, V engine crank. But the exact answer is the direct crank and reverse crank can be found when you have what? When you have what? When you have what? What is this? When you have? Come on, class. When you have common crank. It doesn't matter whether they belong to radial or belong to V engines. As long as you have common crank, you must have direct and reverse crank. Okay, as you have common crank, typically some other engine, for example, not radial, neither the V, but you have another engine called whatever it is. But as long as you have common crank, you can use this method to solve the problems of balancing. Yeah. Okay, now. Okay, the next thing now. Okay, after you understand this one, so this is the place on line of stroke. Remember, as I mentioned here, place on the line of stroke. Now you have half for the crank, reverse crank, the other half for the direct crank. The position is exactly the same. The other one only you have negative because it fall below the level line. Okay, so when you add up together this one, you add up this one and you add up this one, you become M again. isn't it? Okay, so that is where you have to understand what is the crank and reverse crank and direct crank. After you understand that, then you have to move the next one. This is how the procedure of measurement. I did underline all the keywords here. The keyword is from the line of stroke to common crank. Look at all the keywords, it's the same keywords. Yeah. So look at here. Remember that one just now? If I can write something here, remember just now? I'm not going to. If I'm going to share with you. I'm going to bit class. I'm going to write something. Okay. Now you already understand that you have here this one R, this one L, this one M. You balance it by putting mass here, M just now. Because you have common crank. When you common crank, you will have what? You will have direct crank, you will have reverse crank. So this is direct crank, rotating counterclockwise from your seat. So the reverse crank will be the image of the crank that you have. So you provide another crank. So you provide another crank exactly as the position and also connected to the same mass. So this one another mass. So this is no longer M, become M divided by 2. This one is M divided by 2. And this is the line of stroke. And when this one is rotating counterclockwise, this one be rotating clockwise from your seat. This one is counterclockwise. This one is clockwise. You already understand this one. So this one is what you call line of stroke. Okay. Now, after you understand this one, look at here. So primary direct crank. So before that, we have another one. Just now your force now is equal initial, yeah. Your force initial is equal to F primary plus F secondary, or it can also be in terms of M omega square R cos theta plus M omega square R cos 2 theta divided by N. Focusing on this one, you will have F primary is equal to F. I do see that primary by the secondary. It's not correct. This one is F primary. Now it's not vector. This one will be F primary, also primary, but direct crank plus another F primary, but now what? Direct crank and reverse crank. So what will be the equation? Same equation being used. Equation be M omega square R cos theta. This is the equation. So if I pick up only one, for example, F primary or direct crank, for example, you'll be using the same equation, cos. Okay, but remember, yeah, this one is no longer M, it become 2, isn't it? Because you have 2 crank now. So you have N, you have F primary, but now it's reverse crank. Reverse crank is equal to M omega square R cos theta. But this is a part of the primary, so divided by 2. So that is why you have this one. Oh, sorry. This one, half of the mass. Okay, after you understand the one, I'm going to move this one. Okay, okay there. The position, the primary direct crank is what measured from the line of stroke to common crank. Line of stroke to common crank. Remember, yeah, line of stroke to common crank is the keyword. Where is the, by following the given direction. What does it mean? If the given direction is clockwise, follow. If the given direction is a counterclockwise, follow this one. If the given direction is clockwise, follow the clockwise. So that is the primary direct crank. You may not understand this one because you don't have an example. After you have the example, inshallah, I can guarantee you will totally understand this one. It's very logic and also clear about creating or constructing the crank diagram later on. The next one, this one is reverse. This one direct. This one reverse. Primary reverse crank. Measured where? Line of stroke. Two-way common crank. But opposite, because this one is opposite. Remember just now, theta and negative theta. Opposite. Why? Because this is the image. So as the opposite, it simply means that if this one rotating clockwise, this one be rotating. Sorry, if this one rotating counterclockwise, this one be rotating clockwise. Okay. This one you understand. This one, inshallah. Yeah. So the second one, secondary crank. Secondary is twice. What is the keyword? Measured on line of stroke. Two-way common crank. But now twice, because secondary, twice of the crank, or sorry, twice of the primary goes following the given direction. For the secondary reverse, where is the measurement? Is measured from the line stroke to where? To common crank. Twice also, but opposites. Because reverse. You understand this one, inshallah. Yeah, the next one is not very difficult for you. Okay, how to use this one later on. Be patient, inshallah. I'm going to explain to you, no, part by part. Any question? Excuse me. Any question, class? No. Any question? Thank you, Cole. Okay, now. 1 minute now. Okay, this is the unbalanced primary and secondary force for the radial and B engine. Remember the unbalanced? The unbalanced is basically coming from the equation F equal to m omega square r cos theta. Sometimes I put this one m r omega square, same thing, yeah, plus m omega square r cos 2 theta divided by, this is the unbalanced primary and secondary force. Okay, look at this one. This one also not big deal. I already mentioned this one earlier, right? This is now what I've been talking earlier just now. Okay, let's assume that you have this one m. So this one become m, but you have another one, isn't it? You have another one. Put it here, another one. So this no longer m, become m2 divided by 2, m divided by 2. As you put up this one all together, will bring you, it's so logic, alright? So you have force here. We have force here. The force will be what? What will be the force? What will be the force? What will be the force? You have m omega square r cos theta, isn't it? If you're talking about primary, for example. So the same thing, the same m force will be here. So this one, also same thing. You have m omega square r cos theta. But it is not only one crank. You have two cranks to divide it by. Okay, so this must be another one. Same thing. You have this one m omega square r cos theta, also divided by 2. So if you have this one, and you have another this one, and this one you add up together, you become this one m omega square r cos theta. It's so logic, correct? So because you're half m and half m. You have another one pointing upward, becomes sine. You have another one pointing out, becomes sine, and this one be pointing opposite direction. It will be totally cancelling off automatically, correct? The product, or perhaps the resultant of these two forces in component x and y, you have this one. This one is initially you have m, what, omega square r, but you have 2 now, so divided by 2. It's also divided by 2. Right? Of course, you cannot add up this one because this one is vector. You have to add up this one, yes, because the same vector. You add up this one and become 0. Okay, so that is how do you find basically on what you are going to look later on. This is primary, yeah. Talking about secondary, if primary is theta, secondary now is twice 2 theta. Its primary is omega. This one becoming 2 omega. Same arrangement. Same arrangement. The difference now will be divided by n and divided by n, because you have this one cos 2 theta, cos 2 theta. Okay, you have this one also. This one is much clearer. This one just to share with you. This one what is been doing, what is occurring on one cylinder. Okay, so this one is for one, cylinder. Get here. You have this one. You add up together. You bring here, and this one and the other one can be cancelled off. Right? This is the one. It's not balanced. Okay, this one is not balanced. Okay, so that is for the new equation now. The new equation now, as I've been doing this one, I mean another simple equation to ensure that you basically know that I put it the n here and I divided by 2 here. So this n representing by number of cylinder. If you have 6 cylinder, for example, you multiply by 6. Okay, this one is this one n will be number of cylinder. Okay, here you have only one, so only here you have only equation here. So this equation what we're doing here in the inline engine, now converting for the radial to become as such. Okay. Same thing for the secondary. Look at the secondary. This is what you have. This is the mass for what? Direct crank. Same thing. But now you have another one. That is, so you divide it by 2. You divide it by. You add up together this one. Will give you. That is for the equation that you have F secondary is equal to F. This one also secondary. But for what? For direct crank plus also secondary. But not for reverse crank. Of course, this one be in terms of vector. Okay, and the equation now, what you've been doing in the inline engine, turn up to become this one. The only change will be divided by 2 and also n. Multiply by n and divided by 2. The rest not change of the equations. Okay. Any question up to here? Any question? The next thing I'm going to explain about crank position before we move to the next one. Yeah. Okay. This one I already shown you earlier. Look at example. Before we do example, I'm going to share with you how are we going to basically balance the engines. We do this one. 4-cylinder radial engine. It doesn't mention about whether it 2-stroke or 4-stroke. It doesn't mention the equation usually not mentioning firing order. The equation usually not mentioning firing order. The reason is why, yeah. The reason is why because what? Because what? M equal to 0. Remember? Isn't it? Yes or no? When you have the moment, you have couple of moment here, you need the magnitudes. If you are dealing with force, you are dealing with force only. Force only. So the crank diagram, good enough. NOUGH to solve the problem. But when you have moment couple, you must have what? Magnitudes. You must have magnitudes. Due to what? Due to what? Due to space between cylinder. Isn't it? Here, this one equal to 0. So we need only So we need only crank diagram. Understand me not? Understand me not? Yes or no? Yes or no? Okay, now. So crank diagram. I'm going to focus on the crank diagram. Is a 4-cylinder. Okay? Look at here. 4 cylinders. Theta is equal to, okay, because we are not dealing with engine, yeah, so, whether 2-stroke or 4-stroke, because there is no firing order, isn't it? So theta is always 360 divided by, and this one 4 radian. For radian only. Doesn't matter. It is 4-stroke engine or stroke. For V, we will deal. For V engine, we will do later. Okay, now focus on radian. Okay, crank diagram 4-cylinder. So how is it? We will look like so. So look at here. They will give you 4-cylinder. They will give you one location or position of crank of common. They must provide you. If they do not provide, you have to make your own assumption. The other one will be the direction or rotation of first number of cylinder. The one is location of position of common crank. The other one be direction of rotation of crank. So now 4 cylinders again. Okay, 4 cylinders. So this is the located in one circle just now. This one is your cylinder. For example, yeah. So the crank will be located here. So everyone will connected to the crank. Everyone will be connected to crank. This is common crank. So common crank at 90. Oh, sorry. It's not 90 degrees. At 0 degrees vertically. At 0 degrees. So your 0 will be here. This one be 90. Okay. So remember I did mention about just now. What is the keyword just now? Could anyone tell me what is the keyword just now? Keyword of balancing or procedure. Keyword of procedure. Or formulation. Yeah. Keyword of formulation. Formulate. What is the keyword formulation just now? Could anyone tell me? If you don't respond, I'm not going to, I'm not going to help you in this one. What is the keyword just now? What is the keyword just now? Keywords. Yes. Anyone? Hello? Speak up. You can speak up, yeah? If you don't want to write, you can speak up. It's not direct and reverse. Done. What is the keyword just now? Look at the procedure. What is the keyword just now? What is the keyword? Anyone? What is the keywords? Okay, if you don't want to answer this one, I straight to solve this one. So you do. If you don't understand this one, it's basically for you to understand the next one. What the keyword just now? It's not equal to 0. What is the keyword just now? Speak up. You don't want to write, you can speak up. Hello? What is the keyword of formulation just now? What is the keyword? Go back to your notes. Look at here. Common crank is not the keyword. What is the keyword just now? Anyone else? Anyone? What is the keyword from this slide? What is the keyword from this slide? Class? What is the keyword? The most important thing, keywords. What is that? Okay, I count to 3. If you don't want to, you don't want to answer, I leave it like that. Line of stroke, yes. Another word. Twice, yes. Another word. The keyword is what? Line of stroke is correct. Twice is correct. Another word, very important one. What did I mention just now? From line of stroke, yes. Yes, correct then. Measured from this one. Measured from where? Line of stroke to where? Common crank. So that is the keyword. So now if you have this one, so what is the keyword now? If I'm numbering this one is 1, 2, 3, and 4. Your keyword is what? Keyword now is measured. You have to measure it from where? From line of stroke to where? To common crank. So make full of this one and solve this one. Well, so I do have, okay, first I'm creating or constructing the this is the primary direct crank. Primary direct crank. You have primary reverse crank. The primary direct crank, your theta now is equal to 1. We have theta is equal to just now 360 divided by 4. It make you 90 degrees. So this one, everyone will be 90 degrees. So theta equal to 90 degrees. So your crank diagram will be, so this is your crank diagram will be this one. A cylinder, oh sorry, it's not cylinder, sorry. It's circle made by the crank. And it is rotating counterclockwise, for example. This one must given, yeah, must given. So now I'm creating now crank diagram. Okay, crank diagram. Putting this one line of stroke, line of stroke. So this is my crank pointing at 1 degree, cylinder number 1. And it is rotating counterclockwise omega. Theta degrees. So if the cylinder now 2, 3, and 4, so in measured from line also 2 common crank, so 2 will be here. In measured line also 2 common crank, 3 will be here. In measured line also 2 common crank, 4 will be here. You understand me or not? Why? But the keyword say that line of stroke 2 common crank. So let's put the working. 1, 2, 3, 4. Let's put the answer. This one is working, yeah? This one is your answer. Don't do this one in test. This one is just to help you how to, to basically understand how it works. Rotating clockwise, counterclockwise. This one is a reference. Why I say reference? Because crank fall at cylinder 1. So this one will be reference. What does this mean? It say that measured on line also 2 common crank. So the common crank and the common crank and also the line also fall at the same place. So that is why this one is reference. But cylinder number 2 is here. So measured on line also 2 common crank. How much it go? 90 degrees. How do you know? Because theta just now is 90 degrees. 90 degrees. So cylinder number 2. The next one, cylinder number 3, is also rotating. This one 180. 180 measured from reference. Now is 3. This one 4 will be also measured. This is line of stroke. Line of 2 common crank. So it will be 4. Understand me? So your F primary for direct crank is equal to, this one is primary direct crank, yeah? What is the equation just now? N, then you have M omega square R cos theta divided by 2. Correct. So that is the equation. How many cylinders you have? 4 cylinders. What is the M? M will remain M. R will remain as R divided by 2. Yes. The omega is a constant parameter. So what difference is theta, cos theta? Cos theta will locate at 0. So cos 0. What? So what do you have for cos 0? Cos 0 equal to? Cos 0 equal to? Anyone? No? Yes, 1. So it become 1. 1, normally we don't put 1. So the answer will be U is equal to 2m r omega square Newton pointing upward. So this is the unbalanced one. You understand me or not? Yes or no? Okay, next. You have one. This one is direct. This one is reverse. What is the difference between direct and reverse? Anyone? What is the difference between direct and reverse? You don't want to answer this one. I don't want to help you this one. What is the difference between direct and reverse? What is the difference between direct and reverse? Anyone? Opposite sign, correct. So if this one or rotating 90 degrees, this one also rotating 90 degrees, but now theta equal to negative 90. Isn't it? Negative 90. Okay, so we are going to do another one. This one is a primary reverse crank. Theta equal to negative 90 degrees. So this is this one is number 1, number 2, number 3, number 4. This one is the crank. This one is the equation. This is your equation. This one is working, yeah? Okay, put it working. This is your answer. Rotating. This one is reverse. Look at the reverse. This one is also reverse. Oh, sorry. This one is not reverse yet. This is the direct because this is working equation. This is your answer. Oh, the color is not, it's not good. Okay, sorry, yeah. So now, what does it say just now? Measured on the line of stroke 2 common crank. Remember that one, yeah? Measured to where? To line of stroke 2 common crank. Sorry, measured from line of stroke 2 common crank. So from line of stroke 2 common crank. Now opposites. Because why? Because this is the reverse. Measured from the line of stroke. This one line of stroke. Sorry, this one line of stroke. This one also crank. Correct. So number 1. Now measured from the line of stroke. 2 common crank. Common crank is here. But now opposite. So this one is opposite. Yes or no? Yes or no? Yes or no, class? Yes or no? I don't know whether you understand or not. I understand. I totally understand this one. Isn't it? Okay? So you have to understand that, this one is primary. You have to go to 90. You have to go to 90. Measure to lines of 2 common crank. But now 90 negative 90, isn't it? Only 90. Only 90 because you have 90. This one you go what? 270. It's not correct. You only go negative 90. Correct? So 3 will be 2 will be here. Yes or no? This one you go negative 90, negative 90. That's not correct because cylinder to only 90 degrees. So it will go 90 degrees. Let me put it this one. This one is direct just now. Now is reverse. Put another color. Reverse. Negative 90. Correct or not? Yes or no? Yes or no? You don't want to answer, never mind. When you ask me, I also don't want to answer you. Yes, isn't it? 90, this one negative 90, correct? Now look at 3. 3 now will move one. Measured on the line also 2 common crank. This is line also correct. 2 common crank. It goes 180, correct? But opposite direction. So opposite direction, what does it mean now? Will be what will be moving? That one. Opposite direction. So 3 will be here. Oh, I put another color. Supposed to be another color so that you can easily see the difference. Huh? What color is that? Yes, correct. So now measured online also 2 common crank. This one. But how much it go? 180. How do you know? Because from the primary, direct is go 180. So it go 180, 180, but opposite direction. This one is negative 180. So if I pick up only one cylinder, yeah, for example, one cylinder, to make you understand. Number 1, number 2, number 3, number 4. Focus on 3 only. Put it another color. Put it another color. Okay, now this is the given one, primary. This is primary. Primary direct. Okay, cylinder number 3. Go 180. Isn't it? Primary direct go 180. So primary reverse, it will go what? It will go what? Primary reverse. It will go, it will rotate. Come on, 180, negative 180. So where will be your negative 180? Your negative 180 will be here, isn't it? Opposite direction, negative 180. You understand me or not? Yes or no? Yes or no? Yes, thank you. Okay, so this one be cylinder number 3. Number 4, look at number 4. Look at number 4. Look at number 4. One minute, huh? Number 4. Focus on number 4 now. 1, 2, 3. Focus on number 4 only. Focus on number 4. This is crank, common crank. So number 4, move this one. Isn't it 90 degrees? So what will be the 4 move for the reverse? Also 90 degrees, but opposite direction. So negative 90. So you have 4 here. Balance not? It is balance. How do you know balance? Balance. How do you know balance? Because we have 2 at bottom and 2 at top. So if you construct a polygon, for example, yeah, you construct a polygon, you will have what? Then the line will go back, come back to the original. And of course, this line is overlapping, or superimposed. Okay. Understand me or not? I do just now a shortcut way for cylinder number 2. Never mind, I will explain another time for cylinder number 2. I do it shortcut way just now. Any question? Okay, now go for secondary class, secondary. This one secondary. What do you understand by secondary just now? Is 2 theta. What does mean 2 theta? 90 now become 180. Isn't it? So how is it? It's not very difficult. Look at here. 1, 2, 3, 4. We are constructing now is a secondary direct crank theta. 2 theta is equal to 180. Now you don't have omega, you have 2 omega. Right? So now look at this. Cylinder number 1 become reference because will fall at the same position as line on stroke and common crank. So your answer, this is your working, yeah? Working. In the exam, you don't have to do this one. I purposely do this one to ensure you understand. Now you have 2 omega. Right? So now you have cylinder number 1. Put it here, omega for primary. Because this is the equation. Working is from your equation. This is your answer. Okay, now. Cylinder number 2 measured from line also 2 common crank. How much it go? It goes 90 degrees, isn't it? It goes 90 degrees. Correct or not? Yes or no? Yes or no? No one dead. No one to answer. Okay, done. So now for secondary, how much it will go? So for secondary, how much it will go? How much cylinder number 2 will go? 180, correct. So if it's not end up to here, will be what? Will be moved to the next segment. So 2 will be here. Yes or no? Look at number 3. I'm going to clean up this one. Look at number 3. Number 3, use another color. Look at number 3. Measured on line also 2 common crank. The keyword. How much in number 3 go? You go 180. Correct. For primary. For secondary, this one for primary. For secondary, 3 will go. For secondary, how much? For secondary, how long go? 360. Correct. This one for 360. Secondary. So 360 will fall back to the original position. So 3 will be here. Okay. Look at number 4. Number 4. I'm going to clean up this one. At number 4. Number 4. Number 4, yeah? Number 4. Number 4 now, measured on line to 2 common crank, follow the given direction. It goes what? Number 4, it goes 270 for primary. Now, for secondary, how much will go? How far will go? How far will go? 270 become? 270 become? 540, correct, 540. And very difficult for us to define 540. So now we start. We start what? Could anyone spell it out? Start what? Start what? Counting segment. We start counting segment. How is it? So is 270 is basically 3 segment. So 540 become how many segment? How many segment? How many segment? 6 segment. How is it? Look at here. 1, 2, 3. 3 segment. Now it becomes 6 segment. 4 segment, 5 segment, 6 segment. So number 4 would be here. It's easy for us to counting segment rather than add up the position of 180, 180, 180. Just imagine you have 12 cylinder later on. It's very difficult for you to look at 12 cylinder. It's 30 degrees each, isn't it? So you have to add up 30, 30, 30. Very difficult for you. So we are start now counting segment. Okay, start counting segment. Why? Because why? Because the segment that all in one circle is basically equals. Okay, now look at the next one. So does it balance? No, it is balanced. Okay, now do another one, secondary also. Secondary theta equal to 180. But now we are talking about reverse crank. Secondary reverse crank. 2 theta equal to negative 180. So this is the equation from the equation. Equation 1, 2, 3, 4. Rotating that way. This is this one, crank. So this is your answer. Your answer. Cylinder number 1 be here. Why is number 1 here? Why? 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 You don't want to answer the one, I will leave it like that. So you have to check on you have to look at or find on your own. What's number 0 degrees correct? Another one I did mention just now. Another one. What we call it? What does we call it? As cylinder number 1. Reference, yes. It is reference. Why reference? Because the crank diagram, because the common crank fall at line of stroke. It is a reference now. Supposingly, put it here. 1, 2, 3, 4. So this is crank. Common. So now tell me, where will be your reference now? 2 will be reference. So the reference will be always what? Always be at the position of the crank, because the crank fall at the line of stroke of that particular cylinder. Okay? Okay, now we move to this one. Okay, let's see another one. Let's say you have another one. This is most of book give you this one. Most book, yeah. Suddenly you found that the crank will be here. Number 1, number 2, number 3, number 4. What it end that way? This is common crank. So now tell me, let's say common crank at 45 degrees. So tell me now, where will be your possibility of your reference plane? You don't want to answer this one, I will leave it like that. You have to check on your own. Because most book will be giving you this as this type of question. If you click in question. I count to 3. You don't respond, I leave it like that. 1. Not sine 45. Sine 45. You mean put it at put it at what cylinder? Cylinder number 1 or number 2? 1 or 2? 1. 1. Can it be 2? Can it be 2? Can, yes. Okay, now this is not very careful. The possibility or the what do you call it, yeah? It's not the easier, the simple one. Okay, the simple method of solving the reference plane is to look at the vertical one. Look at the vertical. Even though you found that the crank is not at vertical, you have to push this one. You have to push it to vertical. Don't do this one. It's very difficult. Pushing the vertical is easy. Because why? Because look at the crank. The crank. Then you have very easy for you to this one, isn't it? This one is very difficult. You have to have a component of x and y. So you have to push it and put it in the vertical. Remember that. Or you can also push it in the horizontal. Then you have that kind of unbalance. Okay, so now come back to this one. This is not in book, yeah. This one based on when you do so many examples, then you know that how to go about it. Okay, now put it here. We are basically at another couple of minutes. Yeah, we are basically at reverse crank. So cylinder number 1 reference correct. Now 2 will go here 90 degrees, isn't it? So what when you are talking about reverse? What when you are talking about reverse? So you will go reverse this one, right? Right. Measured on line of two common crank 90 degrees. Now measure the line of 2 common crank also 90 degrees. So 2 will be here. But remember, this one is secondary. So it is not correct. It is not correct. It's supposed to be where? It's supposed to be where? 4, correct. Huh? Because you are talking about what 180. So we'll move another 80. So you move at 4. 2 will be here. Okay, look at number 3. A bit, yeah. Number 3 now. It move 2 segment. Now start counting segment. For secondary, 4 segment. For secondary reverse, it also 4 segment, right? So now you have 2 omega. 4 segment. 1, 2, 3, 4, 3. Correct or not? Correct or not? Yes or no? Yes. Okay, now look at the last one. Cylinder number 4. Look at the last one, number 4. Oh. Number 4. What do you have? Number 4. Let me put it in another color. Put the green color. So you have number 4. Zab here. How many segment? Measure for line to common. How many segment? How many segment? How many segment? 3 segment. For primary, for secondary, becomes 6 segment. for a secondary reverse for 6 segment, but opposite direction. 6 segment, 1, 2, 3, 4, 5, 6. So this one be number 4. Balance not, it is balance. It is balance. This one, balance. So the thing that not balanced, basically, secondary, this one is balanced. This one is also balanced. This one so in conclusion, before we end our meeting today, in conclusion, we have F primary is equal to F primary direct plus F primary reverse. This one is not balanced, 2m omega square out. This one plus 0. We have F secondary equal to F secondary direct plus F secondary reverse. This one all in vectors, yeah? This one 0 plus 0. So totally, this one F is equal to F primary plus F secondary on vector equal to 2m omega square r. This is the unbalanced parameter. It is pointing upward. It is pointing upward. So if you want to balance the engine now, how to balance the engine? This one just now. This is correct. You have to what? You have to do the here is equal to that value. This one all cylinder. This one all cylinder. It's number 1, 2, 3, and 4. Okay, so I'll be doing inshallah the next meeting. Next meeting will be on the coming weeks, not next week, week after next week. So I'll be applying or perhaps explaining to you more and more examples so that you can understand. Yeah. Okay. So if you feel down about it, you read books, inshallah. If you catch anything that you not very clear, you can ask me. But I will respond to you for those who respond in my class only. The rest will not be responding. Okay, with that, class, thank you very, very much for your time, for your attention. Any question before we move or we left or we close the session? Any question?
Doctor,
Yeah.
can I ask about the triangle engine or the Wenger engine?
The triangle engine?
Yeah, it's not in the topic, but I saw it in the engine the other day. I saw the triangle engine is very similar to a radial engine.
Okay, yeah. Inshallah, there will be, and I think next semester, you have the triangle engine, and also another one is rotary engine. So the triangle engine, as long as you have the common crank, look at the common crank. If you have a common crank, so it is so definite you need to use the direct and reverse crank. Okay. So the keyword is, sorry, the procedure will be what? The procedure, if you have a common crank, doesn't matter what type of engine you have. So you will use as what we have here. At the moment now, we are only focusing on a 2 engine, radial and also V engine. Because the triangle engine and also rotary engine is some other form of engine, but it also has the common crank. But the common crank is not be as what we've done in the radial. Radial is very easy because you have a equi angle. The triangle engine and also the rotary engine, you cannot basically use the theta as well as the V engine. Remember the theta just now I did mention just now? You can use this theta in any of the radial engine. This theta equal to, let's say, 12 cylinder, theta divided by 12. You will have what? 30 degrees. So your theta will be 30 degrees. Your 2 theta will be 60 degrees. Because it will divided by the same equiangle. Isn't it? But the V now, it is not what we've been doing here. The V engine is something else. So the V engine we're going to look later on. Am I answering your questions?
Yes, doctor. Thank you.
Okay, the V now, you cannot use whatever you've done here for the V now. The V has some other parameter. But the procedure will be measured on the line also. 2 common crank is exactly the same. The reason is why it's a common crank. Okay, so with that, I think we have to end our session because we are already run out of time. So thank you, class. Thank you for those who respond to my class. So thank you very much. So we'll see you again, inshallah, next lecture. So stay healthy, stay safe. Have a very good semester breaks. So see you again, inshallah, in the coming weeks, week after next. So with that, I end my session. Assalamualaikum warahmatullahi wabarakatuh. Wish you all the best and have a nice day. Thank you, class.